In this video, we're going to go over section 9.5 from our textbook, which is on functions, angles, and some fundamental identities. So first, let's suppose we have an angle theta that's in standard position, given by this diagram here. Then this here is called our terminal side, and if we pick any point on our terminal side, given by this point here, then the distance between our origin and this point is given by this length r. Now, this r here is going to be equal to the square root of x squared plus y squared, and this is because of our Pythagorean theorem, right? X squared plus y squared will be equal to r squared, equal to this the length of our hypotenuse here, and then solving for r, we'll get the square root of x squared plus y squared. So with this, we can then define our 6 trig functions of theta. So first, sine theta then is going to be our y value divided by our r value. Cosine is going to be our x value divided by our r. Tangent is going to be our y value divided by our x. And then we know that cosecant is the inverse of sine, secant is the inverse of cosine, and cotangent is the inverse of tangent. So those values are flipped. Now we can find the 6 trig functions by using any point other than the origin on the terminal side of an angle. And this is because corresponding sides of similar triangles are in proportion. Right? We can see this triangle here is going to be proportional to this bigger triangle here. So let's look at an example of this. For example, we want to find the values of our 6 trig functions of theta if the terminal side of an angle theta is in standard position and is defined by this here. So first what we'll do, just to make our lives a little bit easier, is solve for y. We have minus 3x plus y is equal to 0. So what we can do is add 3x on both sides, and we'll just get y is equal to 3x. Now, this becomes a little bit nicer. The graph of y is equal to 3x is on the left here. And we have some angle theta in standard position here. So this means our terminal side is given by this line, y is equal to 3x. Alright, so what we can do is then pick any point on the terminal side except the origin. So what we'll do is we'll pick a nice point. If we let x be equal to 1, we see that y is going to be equal to 3. And that is, in fact, on our terminal side here. If x is equal to 1, which is right about there, y is equal to 3, which is right about here. So this is the point on our terminal side, 1, 3. With this information, we can then find our value for r. We know that this is going to be the square root of our x squared, which is 1, plus our y squared, which is 3. Doing so, we'll get the square root of 1 plus 9, which will be the square root of 10. So now we can find the values for our 6 trig functions. We know that sine of theta is going to be y over r. Y is 3, and then r is square root 10. Now remember, if you want to rationalize the denominator then, we need to multiply this guy by square root 10 over 10. And so our final answer will be 3 times the square root of 10 over 10. So then this tells us, since our cosecant function is going to be the reciprocal of sine theta, this will be square root of 10 over 3. Cosine theta then is going to be x over r. X is going to be 1, and r is going to be square root of 10. Rationalizing the denominator, we'll get square root of 10 over 10. And then this tells us secant theta, since it's going to be r over x, this will just be the square root of 10. Tangent theta, we then know is going to be y over x. So this will just be 3. And this tells us that cotangent theta, which is x over y, is then going to be 1 over 3. All right, so that's how we define the 6 trig functions of a problem like this here. Now, looking at another example here, we're given in this figure our r is going to be equal to 1 for each of these 4 points. What we want to do is find the value of our 6 trig functions when theta is going to be equal to this here. And we'll use the appropriate values of x, y, and r in this figure. So we have to determine which values for these points that we're going to be using. So the first thing we'll do here is I'm going to convert theta from degrees to radians. We can do so by multiplying by pi over 180. We saw this several videos ago. Doing this, we'll get 12 pi. We know that one full rotation will give us 2 pi. So this tells us that this is going to be 6 rotations. But either way, the point that we're going to use is 1, 0. So the appropriate values of x, y, and r are going to be given by this here. So to find sine of this guy, this will just be sine of 12 pi, which is given by y over r when y is equal to 0 and r is equal to 1. So this gives us 0. We know that cosecant of this guy is going to be the reciprocal of sine, which is going to be r over y. We know from here that r is equal to 1 and y is equal to 0. So in this case, our cosecant function is going to be undefined. Now for cosine, this is going to be x over r. X is equal to 1 and r is equal to 1, so we'll just get 1 here. So this tells us that secant then is also just going to be 1. Now for tangent, this will be equal to y over x. We know that y is going to be 0 and x is going to be equal to 1, so this will just give us 0. And similarly to that of our cosecant function, cotangent is going to be x over y. So in this case, we will get 1 divided by 0, so this guy is going to be undefined. So this brings us to some function values for quadrantal angles. So we saw from section 9.1, these are angles in standard position with terminal sides along our x or y axis. So these are at 90 degrees, 180, 270 degrees, and 360. So this chart here represents the 6 trig function values at these angle measures here. And as we saw from the last example, we used this point here, which corresponds to 360 degrees. And we saw that cosecant was undefined and cotangent was undefined. Going back to this chart here, we can see that that's the case for 360 degrees. Cotangent is going to be undefined and cosecant is going to be undefined. I'm sorry, this is a typo. This should be cosecant theta. All right. Now this brings us to our reciprocal identities. This tells us pretty much what we already know. We have sine theta is going to be 1 over cosecant theta. Cosecant theta is going to be 1 over sine theta, and so on. And this is pretty clear given our definitions for our 6 trig functions that we've been seeing in this video and in the last several videos. The next thing that we'll look at is our signs of function values. So that's given by this chart here. We also saw this, I believe, in section 9.1, where if we're looking in quadrant 1 here, all of our 6 trig functions are going to be positive. We have all of our x values are positive and all of our y values are positive. In quadrant 2 here, all of our y values are going to be positive, but all of our x values are going to be negative. So this makes cosine, tangent, cotangent, and secant. These guys are all going to be negative. In quadrant 3 here, we have that both our sine and cosine values are going to be negative. So this will make secant and cosecant negative as well. But since tangent is going to be sine over cosine and cotangent is cosine over sine, we're doing a negative divided by a negative, so these guys will be positive. And lastly, in quadrant 4 here, all of our x values are going to be positive and all of our y values are going to be negative. This will make sine, tangent, cotangent, and cosecant negative, whereas our cosine and secant values are all going to be positive because their x values are positive. So, for example here, with this information, we should be able to identify the quadrants of any angle theta that satisfies certain conditions. So for example here, if we have that tangent of theta is going to be positive, but sine theta is going to be negative, we want to figure out what quadrant this angle will lie in. Well, if tangent is going to be positive, that's looking at this chart here, either going to be quadrant 1 or quadrant 3. This is because for tangent, we have y over x, so either they both need to be positive or they both need to be negative. In this case though, sine needs to be less than 0, so sine is going to be negative. We know that in quadrant 1, sine is always going to be positive, so this leaves only quadrant 3. Looking at this next example here, we want to find which quadrant theta lies in if sine of theta is negative, but cosine of theta is positive. Well, in this case, sine of theta is going to be negative in quadrant 3 and 4. All of these y values are negative. And cosine theta is going to be positive in quadrant 1 and 1 and 4. All of these x values are positive. The only one that these guys have in common then is going to be quadrant 4. And we can see that that's the case with this chart as well. Sine is going to be negative and cosine is going to be positive in quadrant 4, and that's the only quadrant where this occurs. And lastly, we want to figure out where cosine theta is going to be positive and secant theta is going to be positive. Well, in this case, looking at our chart here, we know that the only time that they're both positive is when our x values are going to be positive. So that will occur in quadrant 1 and quadrant 4. Alright, let's look at another example here. We want to sketch an angle theta in standard position such that theta has the least possible positive measure and the point 0, 5 is on our terminal side of theta. Then find the 6 trig functions for that angle. So the first thing I'll do is plot this point here, 0, 5. That'll occur right on this point here. So this tells us that our terminal side is going to be right here. So if we have an angle theta in standard position then, this is our initial side along the positive x-axis. So our angle theta is going to look like this here. Now if we want to find these 6 trig functions for the angle, notice that we already have our x and our y value. So what we need to do next is find our r value. We know that this is going to be the square root of x squared, which is going to be 0 squared, plus y squared, which is going to be 5 squared. This will give us the square root of 25, which is equal to 5. Now evaluating our 6 trig functions here. For sine theta, we're going to have y over r, which is going to be 5 over 5, which is 1. This tells us that then cosecant theta is also going to be 1. Cosine theta is going to be x over r. Well, x is equal to 0, so cosine theta is just going to be equal to 0. And then since secant theta is going to be the reciprocal of cosine theta, this would be 1 over 0, which is going to be undefined. Similarly, for tangent, this is going to be y over x. Y is 5 and x is 0, so this guy is going to be undefined. And then since cotangent's the reciprocal of tangent, this will then be 0 over 5, which will be equal to 0. All right, so the next thing we'll look at is our ranges of function values. So that's given by this chart here. So the range for our trig function sine and cosine is going to be between -1 and 1. For tangent and cotangent, we're going to have all real numbers. And then for secant and cosecant, we're going to have this here. This was also explained in the last several videos when we were looking at the graphs for these functions. So with the information of the ranges for these function values, we can determine whether angles are possible or impossible. So that brings us to this example here. We want to determine whether the following statements are possible or impossible. So first we have cosine theta is equal to -1 over 4. So if cosine theta is equal to -1 over 4, then it must be the case that secant theta is equal to 1 over -1 over 4, which will give us -4. So going back to our statement here, cosine theta is equal to -1 over 4 and secant theta is equal to +4. This actually can't happen. We just showed that if cosine theta is equal to -1/4, then secant theta is going to be -4. So this statement is going to be impossible. Similarly, we want to look at cotangent of theta. We want to see if it's possible for this guy to be equal to 6. Going back to this chart here, we know that the output values for our cotangent function is going to be all real numbers. So this statement is going to be possible. And again, that's because our range is going to be all real numbers. And lastly, we want to figure out if cosecant theta can equal 0. Going back to our range here, looks like 0 is not in the range of our cosecant function, so this one will be impossible. Because 0 is not in our range. Alright, so this brings us to some important Pythagorean identities. The first being that sine squared theta plus cosine squared theta is equal to 1. We can show that this is the case by using our Pythagorean theorem. Remember that r squared is going to be equal to x squared plus y squared. We showed that at the beginning of this video. Now if we were to divide both sides by r squared, on the left hand side here we'd get 1. Then x squared over r squared can be written like this. And similarly, we have y over r squared. We still have 1 on our left hand side. And remember, x over r is equal to cosine. And we have x over r squared, so this will give us cosine squared theta. And similarly, y over r is equal to sine, so this will give us sine squared theta, which is our identity here. We'll do a similar explanation for the second identity. Our Pythagorean theorem tells us this here. If we were now to divide both sides by x squared, on the left-hand side here, we'll get r over x squared. On the right-hand side here, we have x squared over x squared, so that'll be 1, plus y over x squared. Remember, r over x is going to be the reciprocal of cosine, so this will be secant squared. And then y over x is going to be tangent, so this will be tangent squared theta. And that's exactly what we have up here. And lastly, if we were to do the same thing using our Pythagorean theorem, but now in this case divide both sides by y squared, on the left-hand side here, we'd get r over y squared. On the right-hand side here, we'll have x over y squared plus y squared over y squared, which is going to be equal to 1. Then r over y is going to be the reciprocal of sine, so this will give us cosecant squared theta is going to be equal to x over y, and that's going to be the reciprocal of tangent. So this will give us tangent squared theta plus 1, which is exactly what we have up here. So these are three very important Pythagorean identities that we'll use throughout this course. The next identities we're going to look at are quotient identities. So that is sine theta over cosine theta is equal to tangent theta, and cosine theta over sine theta is equal to cotangent theta. So we can also use our knowledge of these functions to show these guys. For example, sine theta over cosine theta, we know that this is going to be y over r, that's going to be sine, over x over r, cosine. This is the same as y over r times r over x, which gives us y over x, those r's will cancel, which gives us tangent theta. Similarly, cosine theta over sine theta is the same as x over r divided by y over r. This will give us x over r times r over y, which will give us x over y, which is going to be the reciprocal of tangent theta, which is the same as cotangent theta. All right, so we'll use this knowledge to do this next example here. We want to find the exact value of each of the remaining trig functions of theta, given the fact that cotangent theta is equal to negative square root 5 over 6. So first, we know that cotangent theta is going to be cosine over sine, which is the same thing as x over y. This tells us that x then is going to be equal to negative square root 5, and y is going to be equal to 6. With this knowledge, we can find our r value. This will be the square root of negative square root 5 squared plus 6 squared. This will give us then square root of 41. Now notice, we're also told that theta is going to be in the fourth quadrant. So, if we're looking in the fourth quadrant, we know that sine theta is negative, and cosine theta is going to be positive. With this information, we'll also be able to determine the sign of the other three trig functions. All right, so sine theta is going to be negative, and sine theta is going to be y over r. Y is 6, and r is the square root of 41. Then rationalizing the denominator here, we'll get negative 6 times square root of 41 over 41. Now since cosecant theta is going to be the reciprocal of that guy, we'll get negative square root of 41 divided by 6. Now cosine theta we know is going to be positive. This is going to be x over r. So this will be 5 over the square root 5 over square root of 41. Rationalizing the denominator then, we're going to get the square root 5 times the square root of 41 over 41. And we know that we can then multiply both of these guys. So we'll get square root of 205 over 41. This tells us then, since secant is going to be the reciprocal of that guy, this will be 41 over the square root of 205. And then rationalizing this guy, we'll get this here. And then we can do one more step to simplify. We divide the top and bottom by 41 here. We'll get the square root of 205 divided by 5 as our final answer. And then lastly, we want to find tangent of theta. We know that the sky is going to be y over x, or sine over cosine. And since sine is negative, tangent is then going to be negative. this will be negative 6 over square root 5. And then rationalizing the denominator for this guy, we get negative 6 times the square root of 5 over 5. Alright, so we found the remaining trig functions of theta given just this information here. And then the last example we're going to look at is the following. We want to write tan theta in terms of secant theta if theta is going to be an acute angle. And from section 9.1, this just means that our angles are going to be, or our angle is between 0 degrees and 90 degrees. Now what we'll do for this one is use our Pythagorean identity, which tells us that secant squared theta is going to be equal to 1 plus tangent squared theta. And what we'll do is use this to solve for tan theta. So we'll subtract 1 on both sides of this guy. We'll get tangent squared theta is then going to be equal to secant squared theta minus 1. And then we want to get tan theta by itself, so we'll square root both sides of this guy. And so we get that tan theta is going to be equal to the square root of secant squared theta minus 1. So that's how we would write tangent theta in terms of secant theta. Alright, so that'll be it for this video.